Alright, hey guys, we're going to be going over just something real quick about just one last part of our unit. And that is just another thing that we need to learn for proofs. And that is CPCTC. Now, you guys don't have to write this down, it's not in your note packet. Just, I want you to know what it means. CPCTC is a short way of saying corresponding parts of congruent triangles are congruent. Okay, what that means is if two triangles are congruent to each other, like ABC and DEF are congruent to each other, what it means is that their corresponding parts are also congruent. Like A would be congruent to D, B would be congruent to E, C would be congruent to F, and then AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. Alright, so that's what corresponding parts of congruent triangles are congruent means. So once we've proven something is congruent by using either side, 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 angle, or angle, angle, side, we can actually prove that any other part of that triangle is congruent to the other triangle by just saying that CPCTC. Let me show you how this works in an actual thing. So on your paper, the first proof, I know this is a bad drawing, but whatever. First proof says you're given that angle KBC, so KBC is congruent to angle ACB. So these two triangles, these two angles are congruent. It also says that angle K is congruent to angle A. What we're going to try to prove is that KB, this line right here, is congruent to AC, which is this line right here. So first let's draw our little proof thing. Okay, remember we're going to write statement, reasoning. Statement and reasoning. So, when we're looking at this, should all write number 1. We all know what's going to go here. It's what's given to us. What did they tell us already? Well, it's right next to the given. So all you got to write is angle KBC is congruent to angle ACB. So KBC is congruent to ABC, and angle K is congruent to angle A. Now the reason behind it is it's given to us. Alright, so going on to 2. Just like what we've been doing earlier, let's look at the thing itself. What do we know? It's true. What do they share? Remember, they share a common side. Both BKC and CAB share a common side, this third side right here. So what we say is it's congruent to itself. So we can say that BC is congruent to BC. So BC is congruent to BC. Why do we know that? Well, remember it's the reflective property. So it's the reflective property. Now let's go back to see if we have enough stuff to actually prove it's congruent. Well, we have one side and 2 angles. So we have a side that's not in between the 2 angles, so yes, we actually do have enough. We know it's congruent by angle, angle, side. So angle, angle, side. So we can say that triangle KBC is congruent to triangle BC. Actually, hold up. Let me put these in the right order. KBC is congruent to ACB. That's what I want. Okay, so KBC is congruent to ACB. Why do we know these are congruent? Angle, angle, side. Now, last but not least, we had to prove that these two sides are congruent. Well, now that we've proven that the two triangles are congruent, we can just say that KB is now congruent to AC. Why can we say that? Well, we just proved that the two triangles are congruent. So because of our little thing that we just learned, corresponding parts of congruent triangles are congruent. Okay? As you can see, KB, AC are in their corresponding parts, so that KB is congruent to AC. So corresponding parts of congruent triangles are congruent. So we just shorten it by saying CPCTC. I'll give you guys about 30 seconds to write, actually, give you a little bit more than that. Write all that down. Alright. Moving on to the next one. Okay, so you have these two triangles right here. Okay, so we know that BA is congruent to DA. So BA is congruent to DA, and we know that CA is congruent to EA. So that's what they gave us. So once again, we're going to draw a little statement things. Okay, so statement, reasoning. Alright, so first is what they gave us. So let's write down what they gave us. So we're going to write BA is congruent to DA. Alright, we know that CA is congruent to EA. The reason why we know that is they gave it to us. So we write given. Alright, let's go back to this triangle over here. So we know that these two sides are congruent. We know these two sides are congruent. The next thing we have to prove is this. That these two angles are congruent. Now, remember, think back. You gotta look at it and tell me what they are. So, what you should say they are vertical angles, or angles right across from each other. So technically, two. Angle CAB, so we're going to say angle CAB is congruent to angle EAD. So angle EAD. Why do we know that? Well, they're vertical angles. No, these are angles, so I'm trying to make them a little bit better. Okay. Now, do we have enough information? Well, let's check. We have two sides, an angle in between. I believe that is side, angle, side. So we know they're congruent. So remember, we've got to write this out so that corresponding parts are actually in the right place. So we're going to say that triangle CAB. So triangle CAB is congruent to triangle EAD. The triangle EAD. We said these are congruent because of side, angle, side. Last but not least, they tell us that, or we're trying to prove that angle C is congruent to angle E. We know that's true because of corresponding parts of congruent triangles are congruent. That's all that extra thing does. CPCTC. Alright, once you get done writing this down, get to work on the worksheets that are going to be passed out. And they're due at the end of the hour to make you guys, or at least the proof one is due at the end of the hour. The homework is going to be the extra sheet that's going to be given to you. So, yeah, get that turned in by the end of the hour. There will also be a answer key at the front of the room for you guys to check your work, not to come and just copy. I've instructed the sub to not give it to you, so you can look at it, but do not take it back to your desk. Alright, thanks.